Hi, in this documentation, I'm going to talk about my project, which is an EEG instrument built in TouchDesigner. Right now, I am wearing my EEG headband. I'm using a Brainbit headband and I'm going to get data from that using Python, and I'm going to send that data to TouchDesigner using OSC signals. I'm using Brainflow library, and as I mentioned, I have a Brainbit headband, and I get the data from the board using this command, and I print the data and I send the data using OSC signals and on this network port, and I'm receiving the data in TouchDesigner, and I convert it using a convert that, and I take the only 4 channel signals and I apply Kalman filter here. I made a container like this, and let's go inside. I have a Python code. I get help from ChatGPT here to apply Kalman filter using Python. I have 4 parameters here and I tuned them as I could. And yes, I output the filtered data here and I merge them. And after that, I upsample the data and using a high value for FFT size, and I visualize the data, the FFT data here. Yes, and so we can see the frequencies, at least the marks of frequencies here. And I also merge the FFT data and the filtered raw data here, and I merge them, and here I use this technique to send this data using OSC signals. I am going to send them to Wekinator. So right now I have a dynamic hard code, maybe, and I use a chop execute that to send this data using OSC messages to Wekinator. Let's open the Wekinator. I have 8. Let's see, maybe. We have many modes of Wekinator, as you know, and let's, for example, let's choose the dynamic time wrapping to recognize the shape of my maybe FFT data. And this works like we can train the data by holding the plus button, and I didn't train the Wekinator yet properly, so I am skipping this step right now. And also I have a synthesizer module here with 4 oscillators. The incoming signal is the FFT data, and I select the channels one by one, and I connect the oscillators to lookup chop. Let me stop the signal here to observe the signal. So lookup chop has an index range, and it scans a function by applying the values of another function and gives the output in the intended index range. So what I do here is changing the wave shape of the oscillators. By default, they are sine wave. So I multiply the signals. One is carrier and one is the modulator, and to create a frequency modulation. And I apply this to these 4 channels as couples to create a stereo, and I also create a mono channel with multiplication of 4 of the signals and give them as a mono channel slightly to create a balanced stereo. So I also have here the average of the 4 channels FFT data, and they are converted to absolute time to create a temporality in the synthesizer. And I also apply a Kalman filter here. So and they are connected to audio parameter EQ chop, which has formant values, and it determines the peak value of the formants. So I have variable, I don't need those operators, let me delete them. So let's hear what we have here. I know it sounds bad, awful right now, but only for demonstration, let me show you some parameters with this audio. So I have also frequency and offsets of the of the oscillators as variable, which will be controlled with Wekinator. So this is a variable, the index range of the lookup chops. Let me 1.5. Let's play around with the bass frequency. The offset. And the wave type. So I have also the formant values. So the timbre related parameters are now fixed, and I want them to be controlled in real time using Wekinator or another AI bot. And the temporal parameters, such as the LFO I created with the common featured spectrum data, are controlled with raw EEG values without AI. So let's listen for a while. This is my work in progress.